Okay, so that's what I used to fill out this whole table. And the reason why I did this table is I want to point this out to you. So look at the column of the conditional. It is true, false, true, true in that order. And when you look at the column of the contrapositive here, it is also true, false, true, true. That means that they're equal. These are equivalent. These are equal statements, okay? Now, we can investigate this just a little bit further and look at the converse being true, true, false, true, and the inverse being true, true, false, true. So that's really interesting. There's that interesting relationship, but these two are also equal to each other. So that means a statement, if a statement is given that is the contrapositive, it is the exact same statement logically using reason. If you're given a converse of a statement and an inverse of a statement, those things are the same. Technically. Okay, so let's look at this a little bit more here. Let's see what I said here. Original conditional and a contrapositive are logically equivalent. Converse and the inverse are also logically equivalent. In logic, the conditional statement is always considered to be true, no matter how you feel about the statement. That's the thing you have to understand. That's what makes this math. This is not opinion. This is truly a branch of math, okay? What makes this math is the ability to always consider that conditional statement to be true. All the reasoning falls away if you don't follow it this way. Okay. So just want to make sure that you remember that big time. Hold on. Let me try to make a big star here. So the conditional is always true. All right, so let's keep on going. Let me try to get through this. All right, let's take a look at this first example. I may or may not have experience in this because I lived 12 years in Alaska, and most of those in a bush village. And my employees would bring salmon to work. That's for darn sure. Okay, so if you microwave salmon at work, then I will be mad at you. Now, the best way to do this is to go ahead and indicate what your P and your Q is. And this, you're always given the conditional. Okay. And I know it's called the conditional, and that kind of sounds confusing, like that means you don't know. No, that's just what it's called. It's called the conditional statement. All right, so this is your conditional. So this means that it is P implies P. Come on, Heather. Okay, P implies Q. All right, so P here is microwave salmon at work. Okay, and Q is going to be I will be mad at you. All right, so let's find the converse. So to find the converse, and I put the notation here, and that'll lead you. So please put the notation right. So the converse is Q, then P. If Q, then P. So we go on and we say if Q, so if I am mad at you, then P, you microwaved salmon at work. Okay, see how that works? We just took the same words that were given to you and you just flip them around in the correct order. The inverse says not P, then not Q. So I'll start with if you did not microwave salmon at work, then I will not be mad at you. Now let's stop for a second and let's just look at these as far as the equality. So to make just so you can see how they're not logical statements. So if you microwave salmon at work, then I will be mad at you. We got to stick with this. We say this is true, no matter if you like the smell of microwaved fish to linger in your space for hours or not. This is the deal, okay? So let's look at the converse again. If I am mad at you, then you microwave salmon at work. But couldn't I be mad at you for another reason? For sure. The inverse, so they're not the same, right? Because this statement is true. If you microwave salmon, I'm going to be mad. But this isn't exactly the same statement, right? Because there's other things that could be happening there. The inverse, if sorry, I forgot the F there. If you did not microwave salmon at work, then I will not be mad at you. Again, by the same logic, I could be mad at you for another reason, right? You might have stole a pencil off my desk. You might have, won a big contract that I'd been working on. Who knows? Okay. So you can see that those two are not the same as this first statement. Let's get down here to the last one. The contrapositive is not the Q, then not the P. So if, sorry, if I am not mad at you, then you did not microwave salmon at work. Okay. And that is the exact same statement as if you microwave salmon at work, then I will be mad at you. Those are the exact same statements. These other two, it's kind of subtle. And that's why, excuse me, that's why putting these words and turning them into symbols really, really help you discern whether those are actually logically equivalent or not. And that's kind of what we're going to be doing here. All right, let's keep on going. Let's look at the next one. Same. Find the converse and the inverse and the contrapositive of the following. If I eat this entire cake, then I will feel sick. Okay, so I want to remind you that this is the conditional statement. And remember, it's called a conditional statement because it's like, if you do this, then that will happen. Well, that's a condition, right? Like, if you do all your work, then you will pass the class. That's a condition of the course. Okay. And so, and it's always good for you to go ahead and you can let P equal eat entire cake. And we'll let Q be I will be sick. All right. So, and remember that this is in the form P Okay. If P, then Q. All right. So the converse is if Q, then P. So if I am sick, then I ate the entire cake. But see, there's a hole in that logic, right? Because there could be other reasons why you were sick. The inverse, not the P, then not the Q. If I don't eat the entire cake, then I won't be sick. Now, again, that is the same statement as the converse, but not the same as the conditional statement. And then finally, the contrapositive says, if I am not sick, then I did not eat the entire cake. Okay? All right. Now, there's the negation of a conditional. Remember in the last lecture we talked about I can't think of it. De Morgan's law. I was going to call it De Moivre's law, but that's somebody else in a different class. So De Morgan's law. Okay, we talked about that before, and the De Morgan's law said that if we had P and Q, this was equal to not P or not Q. So this was De Morgan's law from last class. Now, De Morgan's law was only for and or. And I now have to write the entire thing here for you. Remember, you just flip them over. Okay. That was only for and or. Now, this is for the conditional. Okay, so let's see here. It says the negation of a conditional statement is logically equivalent to a conjunction and or the intersection, right? That's another way of saying it, and or intersection of the antecedent and the negation of the consequent. In other words, that's like gobbledygook to read in words, but here it is in symbols. The negation of P implies Q is equal to P and not Q. Okay, now how can we apply that negation here? So this example says, what set of conditions prove this statement false? Hold on, I need to drink water real quick. So the conditional statement is, if you park here, then you will get a ticket. Just no ifs, ands, or buts about it. That's true. If you park here, you will get a ticket. That is P implies Q, right? P is park here. And Q is get a ticket. Okay. So let's translate each one of these into their symbols, and then we can see which one will make this false. Okay. So if you do not park here and you do not get a ticket. Now remember, hold on, let me stop for a second. To make the statement false means to negate the conditional. Let me make sure I explain that. right? That's to negate the conditional. That means that we need to find not P, if P then Q, which we just looked at right here. Okay, just want to make sure everyone else was on the same page, including myself. All right, so how do we write this statement? If you do not park here, so that's not park, and you get a ticket. Okay, so that's not this. We need it to be P and not Q. Okay, so let's look at the next one. If you don't park here, so not P, and you don't get a ticket. Again, that's not the form we need for the negation of the conditional. So if you park here, oh, this is looking pretty good, and you don't get a ticket. So this is the statement that proves the conditional statement is false. So this statement this statement is the negative proves when, let me just say it this way, proves when the conditional is false. Okay, because that's the negative of the conditional. Okay, awesome. Let's keep on going. Now, there's two types of arguments. There's an inductive argument, which is a collection of specific examples and its premises, and you use them and you propose like a really general conclusion. An inductive argument is never able to prove a conclusion is true, but it can prove whether there's weak or strong evidence to suggest that the conclusion is true. An example of an inductive argument would be the Big Bang Theory, right? Like it can't be proven, but there is a lot of science that points that way. And uh it can be proven using an inductive argument because it goes from an idea with a hypothesis until that hypothesis is tested enough that it eventually becomes a theory. So it's not tangible. We don't know exactly how that happened, but there has been enough hypotheses tested against the theory that it's believed to be true. Now we're not going to be dealing with that. We're going to be dealing with a deductive argument, and a deductive argument uses a collection of general statements at its premise and uses them to propose a specific solution as the conclusion. A deductive argument is considered valid if, assuming that all the premises are true, the conclusion follows logically from those premises. In other words, when the premises are true, the conclusion must be true. Okay? Deductive arguments are either valid or not valid. And here's where the truth tables are going to come in. We're going to analyze our arguments through using truth tables. And the reason why you do this is it strips out all the emotion, all the opinion, all of the ego. You get down to like the literal math of it. Okay. And so how do we do that? The first thing we do is we represent each premise symbolically. And then we're going to create a conditional statement joining all of the premises to form the antecedent, the P part. Okay. We're going to join all of them together all of the premises. So we're going to usually have 2 premise. We might have 3, but you'll usually have 2 premises and then a conclusion. So we're going to set this up. Okay, let me see if I have anything written out here more. No. Okay, sorry, my phone's going off. I apologize for getting distracted. Okay, let's see how this goes. And by the way, we join them all. We join them all with an and, right? This symbol right here. And remember that and is another way of saying intersection. And it has to be in both sets. And if I was going to write a really quick P and Q here and just give you the bottom line, it's going to be true, false, false, false. That will be the last row of your table. Now I feel like I need to write the rest of it, so I'm going to write the rest of it. Okay, so that's what that table would look like. So remember, the only thing that's true with an and if they're both true. Okay. All right, and then we're going to create a truth table. If the solution of the truth table is all true, then the argument is valid. If it throws in that last column 1F, then it is an invalid argument. So let's take a look here. All right, so what we do is we put the 2 premise together with an and. So this is premise 1, and this is premise 2. And so the form that we're going to use is premise 1 and premise 2 implies conclusion. Okay, that's kind of how it's going to go. Now, each premise could be complicated. It could be a conditional statement or it could be something else. Okay, so you've got to take each piece one by one. So let's look at premise 1. Let's use these letters here, B and S. So let me get my table going here. So this is going to be true, true, false, false, true, false, true, false. Okay. And then let's figure out what our first premise is. If you bought bread, then you went to the store. So let's let B equal bought bread. And let's let S equal went to store. Okay. So this first little column I built here is premise 1. And then this happens to be premise 2. Now let's look at them a little bit closer, but you might have a couple of columns here where you've got to build it all in here. You'll see it as we do our next example, but so premise 1, if you bought bread, then you went to the store. So if you bought bread, then you went to the store. The second premise says you bought bread. If you bought bread, well, you bought bread. The conclusion is you went to the store. Okay, you went to the store. So those were not compound statements. Those were simple statements. And premise 1 is a condition. Just FYI, wrapping it back to the definitions and stuff. So premise 1 is a conditional, premise 2 and the conclusion, those are both statements. All right, just so you understand. So this is premise 1, this is premise 2. Let's find what premise 1 is. Remember, the only thing that throws a false with a conditional, if we have the conditional, I'm just going to write the last row of the conditional is true, false, true, true, because it doesn't matter if it's false as the antecedent, it will always be true because it doesn't matter. And we explained that in last class. So if you're not sure why, you can go back and take a look. You can do a little bit of research, or you can just trust the table. Okay, so this one is going to be true, false, true, true. Now, the next thing we need to do is this and. I told you up here, we'll have to do that intersection. So let me write that out. That would be P and Q. And that last row of that is true, false, false, false. Because remember that this is the intersection. And this is, they're both in there. So of course they're in the intersection. If they're not in both sets, they're not in the intersection, right? So that only occurs in one situation. So now we're going to look from here. Remember, order matters on the truth tables, here to here. I'm going to take a look. True to true is true. False to true is, and we're doing and, right? So true and true is true. False and true is true. Oh, sorry. My bad, y'all. I'm sorry. Got distracted. Let me look at the right thing. This is our, I can't keep my eyes straight. False and true is false. True and false is false. True and false is false. Okay, let me double check that. Let me check my notes and make sure I didn't mess that up. True and false is false. True and false is false. Okay. All righty. True and false is false. True and false is false. False is false. Okay, just want to quadruple check. All right, now we're going to take a look here at this one because now we have put, check this out. This is premise 1 and premise 2. I know it looks ugly because it's all strung together like that, but you had to do all this symbol making up here to set the equation. Implies C. Can you see that set up there? Right here, this is premise 1 and premise 2. Okay, now we're doing the conditional here. So let's get that final answer. We're going to do the conditional of this guy and our C, which is our S right here, this guy to S. So these are the two rows we're going to focus on here, this row and this row going that direction. So true and true is true. False and false is true. False and true is true. False and false is true. Yay. Now we finish this up because we got all trues here. We can say that this is a valid argument. You could just say it's valid. I don't really care, but valid argument. Okay. All right, let's take a look at the last one. Yay! All right. So Let's take a look at this one. Now, this one's a little bit bigger, right? It got crazy quick. Hopefully you've been working on your homework, and everything. Because I've had to pause this video a couple times, I can't remember if I read can't remember if I read the silly quiz phrase, so let me say it real quick. If I've already said it, I apologize. I am literally running on mere hours of sleep over the past few days. So I apologize if I'm repeating myself, but I want to tell you that the silly phrase for this lecture is a snail challenged me to a race. So I'll repeat that the silly phrase is a snail challenged me to a race. Okay, so let's get to the last example. All right, I encourage you to have fun with this when you do it. Don't get too mad. Come back and look at a video if you need to. You will be responsible for this on the final exam. I have not talked about the final exam yet, but the final exam is 2 problems from the first exam, 2 problems from the second, 2 problems from the third, 2 problems from the fourth, and 2 problems from this section. And one question similar to this is definitely going to be on the test, and the other one will be a Venn diagram. So I suggest that you for sure put a lot of diligent focus in on your 5.2 and your 5.4 homework in this section, okay? And reach out to me if you need some help. All right, so let's set this guy up. So we have 2 premises here. Premise 1, if I go to the mall, I will buy new jeans. So let's set this up. I'm going to write it all out up here. So let's let M equal go to the mall. Let's let J equal buy jeans. Let's let S equal buy shirts. Okay, and then also let's go ahead and figure out our premise here. If I go to the mall, M, if M, then J, right? So that's premise 1. Premise 2 is if I buy new jeans, I'll buy a new shirt. So if J, then S. So our conclusion here, C, is if I go to the mall, I will buy a new shirt. If M, then S. Okay, and then we're going to use truth table to see if this is actually true or not. All right. So again, we're going to lean on 2 things here. We're going to lean on the truth table for and the truth table for the conditional. And I, again, am only giving the final column of those because I don't want to write them all up. This is true, false, true, true. And this is true, false, false, false. Okay. Okay. Now let's just get started here. So we need to do the conditionals for M to J. So true, true is true. True, true is true. When is it bad with the conditional? When it's true to false. So true, true is true. True. Oops, my bad. My eyeballs skipped. So y'all be careful. My eyeballs skipped, but I knew something was up. True, false, false. True, false, false. False, true is true with the conditional. False, true is true with the conditional. False, false is true with the conditional. False, false is true with the conditional. Okay. Then the next one we're going to do is J and S. So these 2 guys here, true, true is true. True, false is false. False, true is true. False, false is true. True, true is true. True, false is false. False, true is true. False, false is true. Okay. Now we have to put the two premise together. This is premise 1 and premise 2. That's what we got going on here. So now we're going to do these two guys. And we're going to go in this direction. Okay. So we're doing the and now. And the only thing that gives you a true is two trues. So we got true, true is true. True, false is false. False, true is false. False, true is false. True, true is true. True, false is false. True, true is true. True, true is true. Okay. Now, we also, this guy right here, this happens to be our conclusion. And it wasn't just a statement like the last example. This is a conditional statement. Okay. So we got to do a little work there. We need to do our M to J. So it's this guy to this guy this way. So true, true is true. True, false is false. Oops, sorry. True, true is true. True, false is false. False, true, false, true is true. Sorry, my brain got fried there. False, false is true. False, true is true. False, false is true. Let me double check that because I know I kind of fell off there for a minute. The only ones that are bad are the true, false. So there's one true, false. There's another true, false. Okay, that looks good. And then finally, this last piece right here is our P1 and P2. If P1 and P2, then C. That's that whole thing put together. And so now we're going to use this row, because this right here, remember, is our if P1 and P2. In this row, we're going to go in this direction. And we're going to do it one more time with this truth table because it is the conditional, and we're going to do it. So true, true is true. False, false is true. False, true is true. False, false is true. True, true is true. False, true is true. True, true is true. True, true is true. So what we have here is valid. Okay. If any F's came up, and you will have some in your homework, but if any F's come up along that last line there, then it is not a valid argument. Okay. All right. Well, thank you so much. I hope that you have a nice day. I'm going to try to get this last video recorded. Have a good day.